First question. Hamad made a rectangular block for his final year project which has dimension 2t cm by 3t cm and the volume is 1800 cm cube. And the question is prove that the total surface area is A equal to t square plus 3000 over t. Before finding the total surface area, we should find the value of k. Value of k, we can find the value of k from the volume given. The formula of volume for rectangular block is length times width times height. The length is 3t, the width is 2t, the height is kt. There we can find the value of k, which is 1800 over 6t square. Then we can straightly find our total surface area. The total surface area is equal to 2 kt, 2 times kt times 2t plus 2 times kt times 3t plus 2 times 2t. And after the calculation, we can prove that the total surface area for the rectangular block is 12t square plus 3000 over t.
Find the value of t when A has a stationary value. Assume the draft t is equal to plus 3000 per t. And next, we can use the dx dt times 24t 3000 per t square to sum with zeros. And the last, we can take the 8t times the 1000 per t square tools. And the last, we can take the answer with t times the 5 cms. Next, calculate the value of A and determine whether A is the maximum of minimum. A times the draft t square 2 plus 3000 per t. This seems like 5. A times draft determine 5 square 2 plus 3000 per 5. And the last, we can get the answer with 900 cm square 2. And the last, we can get the answer with t same like 5 and d square 2a per dt square 2 same like 24 plus 6000 per 5 square 3 and measurement by zeros.
Mega Holding manufactures a cylindrical Bolognese sauce can with a volume of 250 cm cube. The cost of material for the two circular ends and material for the side is Rm 0.008 over cm square and Rm 0.0015 over cm square respectively. Based on the figure, show the function for the cost of material of a cylindrical Bolognese sauce can. Cost n equals to Rm 0.0008 over cm square. Cost side equals to Rm 0.000015 over cm square. Volume equals to pi r square h equals to 250. Pi r square h equals to 250 and h equals to 250 over pi r square. Area equals to 2 pi r square plus 2 pi r h equals to 2 pi r square plus 2 pi r in bracket 250 over pi r square equals to 2 pi r square plus 500 over r. And the total cost will be 2 pi r square in bracket 0.0008 plus 500 over r in bracket 0.0015 equals to 0.0016 pi r square plus 0.75 over r.
Question number 2. Find the sizing that can minimize the cost of material for the Bolognese sauce can. First, we take equation total cost is 0.0032 pi r minus 0.75 per r power 2. We take question total cost from question number 1 is 0.0016 by r power 2. We just power 2 move to multiply with 0.0016, we can get 0.0032, and plus we just convert to the minus, and then r we just add power 2, then 0.75 per r power 2, we just move to the right, and negative convert to positive because we move it to the left. Then 0.0032 pi we move to the right, and r power 2 we move to the left, multiply with r, we can get the r power 3. Then r power 3 equal to 0.75 per 0.003 pi. We want to remove power 3. We just put square root power 3, and at the same time 0.75 per 0.0032 pi, we put square root power 3, and we can get a remove power 3. Then the answer for r is 4.21 cm. R for radius. That is the sizing that can minimize the cost of material for the Bolognese sauce. Then height equation equal to is 250 per pi r power 2. Take equation from question number 1. We just r for value is 4.21 cm. Then we just divide and get the answer for height is 4.49 cm. That is the sizing that can minimize the cost of material for the Bolognese sauce can. Next question is catch the graph of cost Rm with radius of cylindrical Bolognese sauce can and show the minimum point. That is the graph. The minimum is for radius is 4.21 and minimum point for cost of Bolognese sauce is 0.27.
I'm going to continue the question 2. Sketch the graph of cost Rm vs radius of cylindrical Bolognese sauce can and show the minimum point. Total cost equal to 0.0016 pi r square plus 0.75 divided by r equals to 4.21. Total cost equals to 0.0016 pi bracket 4.21 square plus 0.75 divided by 4.21 equals to 0.0891 plus 0.1781 equals to 0.2672. When radius approach 0 positive and cost approach plus infinity, when r approach plus infinity and cost approach plus infinity. Total cost is equal to 0.0016 pi r square plus 0.75 divided by r is equals to 4.21. Total cost is 0.0016 pi bracket 4.21 square plus 0.75 divided by 4.21. It's equals to 0.089 plus 0.1781. It's equals to 0.2672. And the minimum cost is equals to Rm 0.2672 unit.
3. Ramesh works as a designer in ABC Company, which produces the miniature bowling pins (MBP) as shown in Figure 1. As part of his design, he needs to compute the volume of MBP, which is made by rotating the function fx equals to 1/5 square root negative 6x power 6 plus 10x power 4 minus 5x squared plus 1 on the interval 0, 1 along the x-axis. Figure shows the miniature bowling pins. The graph for the function of volume of MBP. I use the equation from above, which is 1/5 square root negative 6x power 6 plus 10x power 4 minus 5x squared plus 1. We can either use the formula y equals to mx plus c to sketch this graph, or we can use a simpler method, which is just to substitute the value of x. I randomly substituted the value of x and get the number of fx. The value we get after substituting is the value in the y-axis of the graph. For example, I substituted x equals to 0 into the equation above and got my value of fx equals to 1/5. And so I substituted it into the graph and plot a few more points in the graph, and I got to sketch the graph perfectly. Moving on to the next question, I calculated the volume of MBP. I used the formula, which is pi integrate from lower boundary to upper boundary y squared dx. I substituted the interval from the question above and the equation and got pi integrate from 0 to 1, 1/5 square root negative 6x power 6 plus 10x power 4 minus x squared plus 1 and squared the whole equation. After squaring the equation, I took out the constant, which is 1/5 and the square root, and got the answer as pi over 25 and integrated the remaining of the equation, which is negative 6x power 6 plus 10x power 4 minus 5x squared plus 1. After integrating the remaining of the equation, I got negative 6 over 7 x power 7 plus 2x power 5 minus 5 over 3 x power 3 plus x. I am supposed to substitute the interval or the boundary into the equation. And so after substituting, I got the answer negative 6 over 7 plus 2 minus 5 over 3 plus 1. The pi over 25 which I took out earlier should be times into the equation and get the final answer as 2 over 105 pi.